folks, we are here to talk more about properties of logarithms, and specifically this section talks about these three, which are the product rule that says log base b, any base of a product can be expanded as a sum of two separate logs. So one key thing to notice here is that you have one log here and two logs when it's addition. Same with the quotient rule. It can be expanded as subtraction. This should be reminding you of the rules for exponents, because remember, that's what the relationship is here. And finally, the power rule. If you have a power like this, and I think I actually mentioned this a little bit in the last video, that can come out front. Okay, so those are the three we're using. So here's what we are asked to do. First of all, let me just remind you that none of those work unless you have the exact same base. Okay, you cannot either expand it, which is going this direction, or condense it, which is going backwards, unless you have the same base. Okay, so most of these are, actually it's about 50-50. It starts out asking you to expand, and these are the directions for the ones to expand. It says, use properties of logarithms to expand a logarithmic expression as much as possible. Notice that it says evaluate expressions without a calculator where possible, meaning they don't want you to use a calculator, but if it's something that you can simplify numerically, then you should. Okay, so we're just going to work a bunch of examples. Log base 4 of 3 times 5. That would be log base 4 of 3 plus log base 4 of 5. And I can't simplify that. Remember that one of the questions we ask ourselves is whether this number can be rewritten as a power of that base. And the answer is no here, so I can't do anything else. All right, log base 6, got an animal here or something on my pen, of 6x. Okay, so that's 6 times x, so that's a product. So log base 6 of 6 plus log base 6 of x. And this time, yes, this number can be written as a power of this base. This actually means just 1. Okay, remember that if the base and the argument match, then your exponent is your answer. And the exponent there is 1. So that whole expression just becomes 1. Not log of 1, just plain 1. And that leaves me with this as my answer. Okay, number 3. Let's do some quotient rule. Okay, if we have a quotient and all of this is expanding, remember, I can expand it as subtraction. So this becomes a 1, and this cannot be simplified, and so this is my answer. Number 4, natural log of e to the 5th over 2. Okay, again, it's a quotient, so that's natural log of e to the 5th minus natural log of 2. Remember, this means the same thing as log base e of e to the 5th. So that we know simplifies as just 5. Anytime the base of your log and the base of an exponent, these two match, okay, the exponent becomes your answer. So this is just 5 minus natural log of 2. Number 5. Here we have a power. Log base x of y to the 5th. Power rule says that power can come out front. Okay, so it's important to understand that using the power rule, it's considered expanding to move that out front, and it's considered condensing to put it back up in there. Okay, so we move, basically when we're asked to, if we're being asked to expand, we don't have any exponents. Number 6, natural log of square root of 5. Okay, we need to remember that roots can be rewritten as fractional exponents. So that can come out front, and there we have it. So again, if we're being asked to expand, we don't want any exponents. That also means we don't want any roots because they are considered fractional exponents. All right, next, let's do some combos. Actually, no, there's one more like that. Hang on. There we go. That one is the same as log, and this is common log, it's base 10 of x to the 1/4 power. And that's going to change by moving that power out front. And there it is. Okay, what number was that? 10, 6, 7, something like that. Number 8. This is where we get into doing combos. And all of this, we're still expanding. Okay, so this is a product, x to the 4th times y. I'm going to separate the product first. Then I'm going to go ahead and move that exponent. So I've got 4 log base m of x plus log base m of y. And that is my answer. Number 9, log base 5 of square root of x over 25. Okay, it's a quotient, so I'll separate the quotient first. Log base 5 of square root of x minus log base 5 of 25. Okay, now this is x to the 1/2 power, so I'm going to write it that way. And this is 25 can be written as a power of 5, which is 5 squared. All right, so then we can take these powers. I like to use a different color. The marker's being difficult. There we go. And move them out. Well, we don't really need to move that one out front. We could. Let's just go ahead and do it that way. Because this is the y. When these two match, my answer is just this. That's 2 times log base 5 of 5. And we already know log base 5 of 5 is just 1. So that's 2 times 1, or just 2. And last one that we are expanding. And then we're going to start contracting or putting them together as much as we can. Okay. Remember that division is kind of like grouping. Everything on top is grouped together. So I'm not going to try to do anything with the stuff on top and stuff on the bottom until I'm not going to try and do anything with the stuff on top here until I've taken care of the bigger issue, which is the division. Started to say that wrong. Sorry. So log base b of x cubed y squared minus log base b of z to the 5th. Now I've got a product here, so I'm going to separate those two as well. Log base b of x cubed plus log base b of y squared, still minus log base b of z to the 5th. And now I can go ahead and take all of those exponents and bring them out front. And I get 3 log base b of x plus 2 log base b of y minus 5 log base b of z. And that is my answer. All right, next we are going the opposite direction. And this is how it's written in the homework assignment I'm really addressing here. Use properties of logarithms to condense the logarithmic expression. This is the other way sometimes this is written, as just write it as a single log. Sometimes that's all it will say, is rewrite this as a single log. And the coefficient needs to be 1. Remember, that's because we said that when we are using this product rule, bringing it down out of the exponent is considered to be expanding it. Putting it back up in the exponent is condensing it, meaning they don't want a number out here. We want to go back to this. Okay, so in all of these, we're kind of going this direction now for all of these. Okay, so let's do this. Where possible, evaluate logarithmic expressions. So that means if we can simplify it, we should. Let's just start over at 1. Now we are condensing. I'm sorry, that should be a 3, like log of 3. It's common log. I apologize. I was thinking it was base 3. Common log of 3 plus common log of 150 is common log of 3 times 150, which is 450. Okay, and this is like a base 10. This is not a power of 10, so I'm not going to simplify it at all. If it was like 10,000 or something, then I would simplify. Okay, let me give you an example. If it was this, that means this, which means that. And so I would say, oh, that's 4. But that's not what we had here. Okay, number 2. log, and this is the common log again, of the expression 5x plus 1 minus log of just x. Okay, so this is subtraction, so that's basically going backwards. It's the quotient rule. We're going to make it a quotient. So common log of 5x plus 1 all over x. Don't try to simplify what you can't. There's not an x in this part, so there's nothing I can divide out. I can't simplify that at all. I'm done. Number 3. 1/3 natural log of x plus 1/4 natural log of y. Well, let's pop these up in the exponent. That's what we do when we're condensing. We don't want anything out front. So we have natural log of x to the 1/3 plus natural log of y to the 1/3. And generally we go ahead and change the fractional exponents to roots. So in other words, this is natural log of the cube root of x, and this is natural log of the 4th root of y. And that is my answer. Number 4. 3 natural log x plus, oh, it was minus. I'm going a little fast here, sorry. 3 natural log x minus 7 natural log y. So again, we can bump those coefficients up and put them in as exponents instead. Okay, subtraction becomes a quotient. And we can stop right there. All right, number 5. 5 common log x plus 3 minus 3 log x. Okay, the 5 is going to come up here. The 3 is going to come up here. It goes together as division. And I would stop right there. Last but not least, we have 7 natural log of x minus 2 natural log y plus 3 natural log z. Sometimes order of operations is an issue with these. You just got to be careful about it. We can't combine 3 things in one step, so we always put them together in the order in which we get them. These two go together first. First, really, I want to move those exponents up. Okay, so that would be natural log of x to the 7th minus natural log of y squared. So put them together as 1. That's natural log of x to the 7th over y squared. And we still have this guy sitting over here waiting his turn. Now it's addition, and let's go ahead and put this up. It's 3. Okay, it's addition, so that's a product. So we're multiplying a fraction times something that's not a fraction. Anytime you do that, even if it's just numbers, let's see. If you're multiplying 4/5 times 3, remember that 3 is really 3 over 1. Anything that's not in fractional form is really over 1. So really, you're multiplying it times the numerator. Okay, that applies whether it's just plain numbers or, in this case, algebraic expressions. So this is natural log, I'm going to write it out, of x to the 7th over y squared times z to the 3rd, which means this is like over 1. So it's going to be natural log of x to the 7th, z to the 3rd, all over y squared. Okay, and that's pretty much all you need to know for this section, which is our section 4.3, properties of logarithms, where we are specifically looking at the product rule, the quotient rule, and the power rule for logs. Hope that helps. Thanks.